Hello friends, welcome to SSP Math. Today we are going to learn one problem on verification of Stokes theorem. So this is the last problem of Stokes theorem. After this problem, in next video we will start Gauss divergence theorem. So problem is verify Stokes theorem for f bar equal to x square I bar plus xyz bar for the surface of a square lamina bounded by x equal to -1, x equal to 1, y equal to -1, y equal to 1. Means we have to verify Stokes theorem on lamina, and lamina given is this is y axis, this is x axis. So how we draw this lamina? First line given is x equal to -1. We know that x equal to -1 line parallel to y axis. Suppose this line is x equal to -1. Second given is x equal to 1. So this is x equal to 1. Okay, then y equal to -1. Y equal to -1 line is this line is say y equal to -1, and then next one given is y equal to 1. So this line is y equal to 1. So suppose this point is A. So what are the coordinates of A? Coordinate of A is -1, 1. This point is B, say coordinate of B is -1, -1. This point is C, coordinate of C is 1, -1, and this point is D, coordinate of D is 1, 1. Okay, so this is the lamina given A, B, C, D, A. Okay, for evaluation, for verification, we have to consider path along AB, then BC, then CD, and then DA. Means for line integral, we have to take closed path along A, B, C, D, and again A, and f bar dot dr bar, how we write? That is x square dx plus xy dy. Okay, so how we take this path along A, B, C, D, A? So we have to divide in 4 parts along AB plus BC plus CD plus DA plus AB again. So is equal to, first take path along AB x square dx plus xy dy. Then we have to take along path BC. Along path BC is x square dx plus xy dy. Then we have to take along path CD, that is also x square dx plus xy dy, and plus along path DA x square dx plus xy dy. So we have to solve these 4 integrals, 1, 2, 3, 4. So now we will take one by one path. So first, if we take suppose along path AB, means this path along path AB. AB, what is equation of line AB? Line AB is x equal to 1, means along path AB x equal to 1 है, x equal to 1 है तो dx क्या आएगा? if we take derivative of both side, dx is 0. dx 0 है तो इस लाइन के लिए देखो, इस लाइन का इक्वेशन है x equal to 1 है, बट y कैसे वेरी हो रहा है? दोनों पॉइंट देखो, यहाँ पर -1, 1 है एंड -1, -1 है, तो y वेरी हो रहा है 1 से -1 तक, एंड y varies from 1 to -1. Okay, so first integral I1 क्या आएगा? I1 means this value of this integral is equal to integration of y varies from 1 to -1 x square dx है, but the value of dx is 0, so this is 0, plus xy dy, but x is -1, so -y dy. Okay, and if we take integration of this, minus sign take outside, integration of y is y square by 2, limit varies from 1 to -1 is equal to minus in bracket upper limit y equal to -1, -1 square is +1, so 1 by 2, and lower limit is also y equal to 1 put किया तो 1 by 2 आएगा, so 1 by 2 minus 1 by 2 is 0, so I1 is 0. Similarly, we have to find I2 now. So for I2, take path along BC line. So equation of line BC is y equal to -1, y equal to -1, then dy equal to 0, and x varies from -1 to +1. देखो इस लाइन में x कैसे वेरी हो रहा है? यहाँ पर -1 है, यहाँ पर 1 है, so x varies from -1 to +1. Therefore I2 is equal to integration of x varies from -1 to +1, y equal to -1, dy equal to 0. If you put here, this term is 0. X square dx is there only. And what is the integration of x square? That is x cube by 3. Limit varies from -1 to +1. Upper limit, if you put x equal to 1 here, so 1 by 3, minus lower limit x equal to -1, if you put here, -1 cube by 3, that is 1 by 3 minus plus 1 by 3 equal to 0. So I2 is equal to 2 by 3. Now along path CD, CD means this path. If we consider this path, so along CD, equation of line CD is x equal to 1. CD के लिए x equal to 1, dx equal to 0, and y varies from -1 to +1, and therefore I3 is equal to integration of x equal to 1, dx equal to 0. If you put here y dy, y varies from -1 to +1, its integration is y square by 2. So after simplification, 1 by 2 minus 1 by 2 is 0. Now along path DA, equation of DA line is y equal to 1, dy equal to 0, and x varies from 1 to -1. देखो x कैसे वेरी हो रहा है, 1 से -1 तक. ओके, and therefore I4 is equal to dy equal to 0 is, so x varies from 1 to -1 x square dx. Now what is integration of x square? Integration of x square is x cube by 3, x varies from 1 to -1 is equal to -1 by 3 minus 1 by 3, means upper limit minus lower limit, this is -2 by 3. Okay, so therefore LHS is equal to, LHS means this is I1, this is I2, I3, I4. If you put all values, then I1 is 0, plus I2 is 2 by 3, plus I3 is 0, and plus I4 is -2 by 3. So this 2 by 3 get cancelled, we get LHS is equal to 0. Okay, now we have to find RHS, and for RHS, take RHS is equal to double integral over the surface, yes, del cross f bar dot n cap into ds. So for RHS, first we have to find del cross f bar. So what is del cross f bar? How we find del cross? So del cross f bar can be written as I bar j bar k bar dabba by dabba x dabba by dabba y dabba by dabba z x square x y 0. Why we write here 0? Because in f bar k bar is not given. So after simplification, this I bar into dabba by dabba y of 0 minus derivative of xy with respect to here z, not with derivative of xy with respect to z is 0, minus j bar into derivative of 0 is 0, minus derivative of x square with respect to z is 0, and plus k bar into dabba by dabba x of y is y, minus dabba by dabba y of x square is 0. So this is y k bar. Okay, and for RHS we want again n cap. So what is n cap? This plane, this lamina lies in xy plane. This is xy plane. xy plane में यदि lamina lie हो रहा है तो n cap क्या आएगा? Z axis is normal to this plane. So okay, if z axis is normal to plane, then n cap is equal to k bar. Okay, and therefore del cross f bar dot n cap, इसकी वैल्यू क्या आएगी? y k bar dot k bar is equal to y. Okay, so RHS is equal to double integral over s y into ds, and what is ds here? Is equal to y into dx dy, because lamina lies in xy plane. Now for solving this double integration, we want limits of x and y, and that are given in problem, or we can draw here one strip. If we draw suppose vertical strip here, this strip enters where? This strip enter where y equal to -1 and leaves where y equal to 1, means at lower end y equal to -1, upper end y equal to 1, and x varies from -1 to +1. So from that strip we can write limit of x -1 to +1, limit of y -1 to +1, this is given in problem, into y dy and here dx, because both limits are constant. So we can take integration at a time here. So how we take integration? We know that integration of dx is x minus 1 to plus 1. Integration of y is y square by 2, y varies from minus 1 to plus 1, equal to 1 minus minus plus 1, and here 1 by 2 minus 1 by 2. Okay, so this is equal to 2 into 0 equal to 0. So RHS is 0. This is equation 2, and LHS is also 0, equation 1. So from 1 and 2, from equation 1 and 2, LHS is equal to RHS. If LHS is equal to RHS, means this is equal to this. So this shows that Stokes theorem is verified on the lamina x equal to minus 1, x equal to 1, y equal to minus 1, y equal to 1, bounded by the from the vector field f bar equal to x square I bar plus xy z bar. Okay, so in next video we will take some problems on divergence theorem. So this is one problem on verification. So with the help of this problem you can solve remaining problems on verification. Okay, if you have any doubt, then please comment on comment section or contact me personally. Thank you.